Hello.
Hey,
Hi. How's it going?
good, how are you?
Doing good. Are you familiar with the platform and how it works?
This is my first time, but I know this platform. I mean, this particular console.
CoderPad? Yeah.
Yeah,
Okay. Excellent. So then shouldn't be too hard to just get started. I'm just going to ask a couple of technical sort of coding challenges, and then at the end, if you have any questions for me, you can ask me then, and I'll give some feedback about how it went on the platform and so forth. So yeah, we can just get started if you're ready.
sure.
All right. So today we're going to be kicking it old school, and we're going to be making change, like in a cash register.
Okay.
So just like we'll start with the basic idea, and then we'll sort of build up on it. But let's just say that you're a cash register software, and you need to find how many coins you're going to give back as change. And so, for example, if you know you need to give 33 cents back in change, you know that you'll give 1/4, um, 1 nickel, and 3 pennies. So that make sense in terms of like what the overall structure is?
Oh yeah. So nickel is 5 cents, right? I mean, I forgot actually.
Oh yeah, no problem. Yeah.
Yeah.
So quarter. So this is like 25 cents. Oops. Um,
Oh,
nickel.
dime. Yeah, I was thinking of dime. Dime is 10. Okay.
Right, yeah. So dimes, and then there's also yeah, pennies is one, and then there's also like a dime is
Hmm.
yeah. So let's start by just we'll have we're just gonna call it not like
Number of.
we'll start just with like figuring out what the actual number is.
Mm-hmm.
So there'll be some kind of number of cents,
Mm-hmm.
and then you will return the number of coins it would take. So in the example above, the answer would be so like num coins of 33 is going to be 5.
Yeah. Okay. I mean, the first thing that was coming to my mind was basically like since it's 33, so like take the highest value coin, that's 25, and then see how many times that goes, and then go to the next biggest number and then go up accordingly. But I'm not sure if that will actually give me the optimal solution, is what I'm trying to think.
Okay.
Will it? I'm trying to think if it will give me the optimal solution.
It will, in fact.
Okay.
See, I'm just gonna change this number for 1 second. Um, and then this is just going to be 3.
Okay. So yeah, I mean, that's what I was thinking. So since, okay, that makes it easy. I can just like mod it then, and that gives the number of. Oh, so the mod will give me the remainder of cents, and when the remainder becomes 0, that means we have got into it, and then okay,
Yeah.
and by division we can get the number of coins for that particular amount. So basically, I have my coins is equal to like I'm gonna like take a list here, basically like 25, 10, 5, and 1, and then basically go while true. I mean, I might have to change that loop, but I'm just running with while true.
Mm-hmm.
And then since sorry, number of coins 0, and now I can do number of coins plus equal to since. Oh, that since by. Oh, so for coins, coin in coins, I guess. So by coin 1, yes, okay, and since equal to divide, I don't know if that works actually, I forget.
Divide equals.
Cents by, yeah, coin. Then return, oh sorry, and just for sanity check, like housekeeping, if equal to 0, return 0. If cents equal to, I mean, one, let's see, 1, return 0. And then return number of coins, I guess. Let me double check. Also, I could also do if cents equal to 0, right. Sorry, I think I'm mistaking. It's something because if it's 25, then cents 25 by 25 is 1, which is not right. I'm just using 1 coin, so that should like just go away. I'm missing something here, something simple. Number of coins 25 mod 25. Oh wait, I have, yeah, okay, that makes sense.
Okay, looks good. Let's just write a little test case here. Let's see how it goes. All right, let's run it and see what happens.
I'm gonna like comment this out, the first.
Oh yeah, that's a good idea.
Oh, of course. Number of coins.
3. Okay, perfect. All right, and what's the runtime of this algorithm?
Runtime is the number of coins, so 4, which is constant.
Constant. Okay, excellent. All right, so you're basically taking advantage of the fact that the greedy algorithm is correct for this set of coins. So you go and you greedily decide how many quarters you need, and then dimes, and then nickels, and then pennies. And that gives you the correct answer. Now, what if I mix it up a little bit and I say you don't get any nickels? Your cash register has run out of nickels, so you only have coins worth 1, 10, and 25. So the algorithm that you wrote, in this case, is going to give you 7, because it's going to be 1 quarter and 6 pennies.
Right.
Whereas the real answer is 4.
Minimizing it basically.
3 dimes and 1 penny.
Okay.
So can you rewrite this so that it will work when your machine has run out of nickels?
Okay. Wait, so is it just to like work? Do we just need to make it work when it's run out of nickels, or do we have to minimize the number of coins?
Oh, you want to minimize the number of coins.
Okay.
Yeah. Sorry. I guess I should really be calling this like min coins. But yeah, just kind of figuring that as a cash register, you're not trying to just give people like hundreds of pennies. You're trying to kind of give people the reasonable amount of change.
Right. Right. That makes me, so like we have to like do some kind of min. So okay, so basically I'll have to do something like, if I'm using 25, what is the number of coins that I get, and what is the number of coins I get if I don't use 25? So it's kind of like a dynamic programming solution, I feel.
Yeah, makes sense.
Okay, I'm forgetting this. Okay, so basically I have to like include or not include and then work with that. Okay. So maybe I have to, okay. I mean, there could be a recursive way, or I could have like a table or like an array of 30, like the input basically. So like 31 cents and like see how much I basically build up to 31 starting from 0, 1, 2, 3, 4 and like using
Okay, yeah, so it'd be sort of what's it called? Just that proof of induction, like an induction.
Yeah.
One way to do it for sure.
And coins.
Yeah, you can just reuse either way.
Yeah. So basically, so I'm going to initialize coins, number of coins basically. Equal to 0 times len of cents. Okay, so I think I see what I have to do here. So basically, and now num of coins. Oh, sorry, coins. That's one, I guess. So basically, having 0 will be 0. But basically, the indexes define the number of cents. So for the 0th index, I'll need 0 because it's 0 cents. So there's nothing needed, and then I can. Okay, so now I have to go 1 cent by 1. So it seems like, okay, for I in range 1 to 30. Oh, not len plus 1 because it doesn't consider the, I mean, in range, the last one is not included. So I'm doing that.
Yep.
So now I have each cent value, and now I have to go through each coins for J in not range, basically coins. So now the value.
Can I get rid of the nickel?
Coins. So basically I have to do minimum. So I'm building from the first value. Coins J, like I'm seeing how many coins I can take from this. So that would be I by J. That's the number of coins I can use from J. Okay.
So is the idea that you, for each, so you're building up this length, you're building up this table with the number of cents, and at each sort of cent interval, you're going to see
the minimum number of coins that I need to build up to that coin, to build up to that cent number.
Right. So then what's happening with the coins of J? What are you doing here? I guess I'm so coins for, so it's like if coins is 25, then I divided by J is the number of coins that of that one denomination that could get you to where you're going, but then there's going to be a lot of rounding issues. So like that's going to be 0 for the first 25. And then, so yeah, I guess
Oh, right.
I'm curious. I mean, I'm just curious as to like what that number is going to represent.
So what I was thinking was basically like my thought process is basically like I'll calculate how many coins I can use from this denomination, and then what is the remaining value that's left, and how many coins did we need to build up to that? So that's one value for. Oh, it doesn't make sense. No, because from getting from A to B, I might need to use multiple coins. From A to B. So I'm building one by one, going from each coins. I have to build for that particular cell. And how do I do that with using all the coins?
So you've definitely identified one correct solution, and you've identified that it's this dynamic programming idea with memoization. So
Right.
what's the key thing that you do when with respect to memoization, you're building up this table. In this case, it's not two-dimensional, but it's just a one-dimensional kind of row. And how are you going to use that table as you are sort of building up the empty rows that you haven't calculated yet?
So basically, for the empty value I'm looking at right now, I'm gonna check. If I use certain coins in this, if I use 25 cents, if I use a quarter, basically, how many quarters do I have to use? And then how many remaining values, how much remaining cents left from that after using the quarters? And then what was the minimum number of coins in that value?
But does that look back into any of the previous values that you filled in? It almost sounds like with that algorithm, you don't even need this outer loop. You just need to run something on that one number itself. Or do you go and look back at some of the cells that you filled in before as kind of a hint for what the current cell is going to be?
Yeah, I mean, I definitely look at the previous cells, right? Like, so like if I'm at like, say 26 or 20, say 30. So I am 30 and then I'll, wait, not 30, say 35. So I'm at 35 and I see I can use 25 once. So I use 25 and then I check what is the remaining value, that is 10. And now 10 needs only one dime. So I check it directly from my cell that I've already filled for 10, which will say 1. And then I use 1 plus 1 that I've gotten now. So that's 2. That's minimum.
Okay. Right? I think I understand what's going on. So you've got some values that are filled in. So I'll just fill in a couple, and then you've got, well, actually, so this is the 4, 5, 6. So this is just the number.
Yeah.
And then this is going to be the minimum number of coins, right? So like at 5, it's just 1 because it's just a nickel. Oh wait, we don't have any nickels.
Yeah. So
But
5, 6, 7, 8, 9.
You kind of get the idea.
Mm-hmm.
And then okay, so here you are at 35.
Yeah.
And then how are you filling in 35 now?
So that'll be 2. And then how I come to that will be like somehow I'm gonna like do a minimum of something. I'm trying to think how do I do that, and basically when I'm at 35, I'm gonna check for the first coin that is 25, and I can see I can use that once. So now the remaining value is 10, and then 10 would have been over here with like 1. So I'll just use 1 from the 25 and then 1 from. Oops, sorry about that.
Oh yeah, no problem.
1 from the 25, and then I'll check what is the remainder value from 35. That's after subtracting 25, that's 10, and 10 required only 1 coin, so that's 2. So I'll save 2, and then I'll go for the next coin 10, and 10 will like have 10 can come three times. So I check for 3 plus number of coins used in 5, which will be 5. So 3 plus 5, 8. And then I'll check how many, if I use just 1.
Yeah. Okay. Yeah, I see. Yeah, that makes sense.
Yeah, but I'm not sure if that's the right way to do it, because like if maybe that is the right way.
I definitely think it's the right approach. It's definitely the right sort of way of thinking about it. But I think if you code it up, it's going to become a little clearer. Or if you can maybe, well, I mean that's sort of a weird thing to say. It's hard to code something up if you don't have the idea of like exactly what you want it to do. But like, so 35 was an interesting one because it started off the sort of the right way. But let's look at 30. Let's look at how 30 is going to work.
So for 30,
go ahead.
For 30, I'll use 25 first. So 25 gets me 1 coin, and then I'll check for how much was the number of coins used in 5. Now 25 is a 1, and then 5, so like 6 coins. So I'll save 6 in my hand, and now I use 10, and 10 gives me 3 coins. So that becomes my current minimum, and then
walk me through how you get 10. How you get 3 for 10?
So I'm using 10 now. So 10 goes 3 times into 30. So I use 3 coins, and 30 mod 10 is 0. So there's no number of coins.
I see. Okay. Yeah, I think that'll work.
Yeah, but I'm not sure that's the ideal way. But I'll try this and see what happens. So like coins j is equal to this. So actually, I guess I'm doing the same thing again. Coins j equal to this. Okay, coins. Sorry, I might have to delete that. I'm just like writing stuff that I think I might need. So coins.
Actually, I just thought of an example that counters yours.
Okay.
Let's say we get to 70.
70. So I do. I use 25. So I'll get to. I'll see. I can use 2 coins, and then what is the value for 20? 20 will be 2 because 10 gets you 2 coins. So that will get me 4.
I see. Yeah. Okay. Yeah. Okay. No, you're right. Yeah, I was thinking if you started with the 10, then you're going to get 7
But
done.
that's minimum.
But no, you've taken the 25 out first.
I mean, even if I use 10 first, like I'm using the minimum basically.
Right.
So,
yeah, and you definitely want to use the minimum. Okay. Yeah. All right. Yeah. Let's keep going with this then.
okay. So coins j is equal to I. This is the number of coins I can use for this. So coins j, if coins j not equal to 0, basically, okay. Temp is equal to minimum of temp, comma, coins. Sorry, give me one. I'm just confusing myself. Temp.
Temp.
Temp, comma, coins. J is the number of coins. Okay, so temp, comma, coins J plus number of coins of cents minus sorry, I mod j. Wait, am I doing the right thing? Number of coins.
0.
Oh, sorry.
Okay.
That's j. Number of coins. Which is okay. Yeah, cents minus this
Okay.
number of coins.
And how do you break out of this while loop?
Actually, I don't think oh, okay. Actually, yeah, I don't think I need a while loop. Sorry. So for Jane coins, this temp equals this. Oh, okay. So I don't need this over here.
Yeah, I think the temp needs to go outside of that.
So coins J. This is the number of coins I need from J. And if it's not equal to 0, then I can, and then temp is the number of coins, and then outside the loop, I can do I number of coins I is equal to temp.
Okay. Makes sense, right? All right. Let's fire them up. See how it goes. So this is all right, and I'm gonna comment this out so it doesn't run. All right. See what we get. We should get 7.
Oh.
Oh, so you get 4, I think. Yeah.
Oh wait, cents. I think what did it do? Oh, sorry. Yeah, that doesn't need to be length. Yeah. 31
cents, 43 cents.
Oh, 0.31. Yeah, that's 4. Yeah.
4. All right. Excellent.
And we can do 70, I guess. 70 and 30.
Yeah, it's also be 4 too. Yeah. All right. Excellent. Very good. So what is the runtime now of this version?
This is order of n. Coins is constant, so I'm doing order of n. Basically, the input, the order of the number of value, the cents, basically.
Okay, makes sense. Now, if you think about this in so it's order of n time, which totally makes sense. Correct. If you were going to really do this and you wanted to have cents potentially be very large. So if you think about it, let's say you're making change for $1,000 and 25 cents, or $1,000 and 10 cents, or something. There is a shortcut you can make at the upper end of the number range. So for example, that if you have some multiple of dollars, then you just use quarters for those, because to a certain extent that you just use the biggest coin.
Yeah.
So can you think of an optimization for this where above some certain number you just use quarters, and below that certain number you use this more sort of exact algorithm to find the perfect combination?
Yeah, so I'm thinking I'm trying to think a reason, but I was thinking my first idea was to if it's over 99 cents, then I have to use quarters for the dollars. But I'm thinking, why should it be not over 74 then? Okay, yeah. So it has to be over a dollar, yeah, including a dollar, yeah.
So is there any so any amount over a dollar, you know that you just use quarters, and then for the remainder you use this algorithm.
Yeah.
Can you go any? Yeah, what's the motivation about a dollar? I mean, of course, we deal with dollars and hundreds of things, and we our trailing zeros and all that kind of stuff. But is there a lower number that you could sort of optimize past? 100 is certainly it's a good one, and certainly anything over 100 cents you can simplify and just say pay all in quarters above that. But can we lower that number somehow? Where did that 100 come from? What properties does it have? Are there any lower numbers that have the same property?
Okay, yeah, it does. Okay, I see the point where we're getting to. So, the lowest number. Oh, sorry, the lowest the highest value after 25 is 10, right? So for coins to be minimum, it has to be either we do minimum of 25s or minimum of 10s. And that break point comes when we go over 40. Because 30, we can use 3 10s and that works. 40, we use 4 10s and that works. And if it's 45, or when it's 50, we can use 2 quarters and that works. So it has to be over 49, I think, when we can just use quarters until it comes to less than 50.
Okay, that is correct. But why? I mean, I think you're you're hovering around the answer, and I think you have a gut sense for it.
Yeah.
But what is that special thing that the number 50 has with respect to these other three coin denominations?
So because we know if the input is more than 50, 25, the quarters basically covers that. Like quarters is quarter needs one or basically 2 coins to get to 50, and every other denominations, they need many more coins to get to 50. So I mean, I'm not sure if I'm using the right, like the actual words you're looking for, but like basically that's what I mean. Like quarters will get to 50 much faster than any other coins,
Right.
and that's why.
But why not 45?
Because
can't you go any lower than 50?
45. It's more than.
I mean, I guess where I'm really going with this is so let's say, so you're not gonna have to write it, but let's just say we have another function here with number sense, and then I give you
an input
coin. So you've created this coins array here, but what if it's an arbitrary list of denominations? Like this could be the number 26, 42, and 89. And
points you mean?
Yeah, exactly. So this could be some kind of arbitrary set of denominations of any old weird number. And you're right that you can totally follow this algorithm if I pass into you the coins. So you've defined it here because I just gave them to you. But this algorithm will totally work if I just supply that list of coins to you.
Right.
The only issue is that is only optimal in terms of time down sort of towards the lower numbers. And there's this optimization that you can make that above some certain number, you don't actually have to do any tough calculations. You can just say, above this number, I can just use the highest denomination and pay for all of them that way. And then below a certain number, I have to do this. So like, for example, like if I pass you coins is like 89, 26, and 1.
Yeah.
Like above some certain number, you're just using those 89-cent coins because that's going to get you the fastest sort of into the range where you have to pay more attention. And so just like you said, like in the case for 25, 10, and 1, 50 is that magic number. Right. Where above 50, you just pay with quarters, you know it. And then 50 and below, then you got to start getting a little, you got to go and do all of the backtracing and the memoization, all the stuff to find the perfect number. So what is that relationship between 50 and these three numbers? And how would you find that for any random set of numbers?
I see. So we have to get the highest number in the coins and the second highest number and see how many times does the second highest number, how many times can it go, or like how far is it from the highest number? So like 10 is like 2.5 times away from 25. So we can use 2 times of 25. Basically, in this case, 26, 72. So like we'll have to use 3 times 89 as the number beyond which we can use 89 all the time, I think.
So what is that number for 89, 26, and 1?
3 times 89, so that's 267.
Hmm. 267. So where did you get that?
So basically what I'm thinking is like how far is, so 89 mod 26 basically. Oops. Sorry.
Oh.
I to just cut that. So oh wait, not mod pi. So that's 3 basically. So 3 times 89, which is 267, is how I got that.
But I should have picked smaller numbers. But I think the number is actually higher than that. So, for example, trying to think, I picked some bad numbers because they're too high for me to reason about. But let's see. Let's try something a little bit. Just try these. It'll make it easier to reason about.
I was going to say 33, beyond which we can use 11 all the time until.
Okay, so that's certainly true, but that's a little bit different than the equation you just gave me.
No, I mean, so 11 by 3 is 3. Now 3 times 11 is 33.
I see. Okay. All right. But what about 15?
15, so again, 45 would be it. So like 15 by 3 is, 5. 5 times 15 would be 75. Like that's my logic. Beyond 75, we always use, like that's the breaking point basically.
But actually, in this case, the breaking point is 15.
Oh, okay.
Because like if you have, say, 18 coins or something, 18 cents, you can still like it doesn't hurt you to just start using your 15-cent coins right away. And also, like actually, let's go back to the original one.
Right? I got the reason now, but I'm not sure how to reason that. Like I know how to do it now, like how to get the value, how to get the breaking point, but I'm trying to see how can I reason that now. So from the examples that we have been taking, I now know we have to get the LCM of.
Yes, exactly. Yeah, that is exactly what you do.
Yeah, but I'm trying to see how that helps.
So yeah, I mean it's a little bit unintuitive, but it's just this idea that the multiples, in a sense, you can think of as it's in the same way that you can break down a product into its prime components. That it's in the same way you're breaking down this number, this larger number, into these sums, and the sums are all going to be some number times a multiple of the some number times, they're all going to be multiples of these coin denominations. So like it's sort of like it's a little bit of 3 times 25 plus 1 times 10 plus 1 times 5 or whatever.
Okay.
When you start to think about it, that's actually 3 times 5 times 5 plus 1 times 5 times 2 plus 1 times 5. And then you can say to yourself, well, wait, I know that everything I'm doing with 1 times 5, or like this piece here, is already subsumed. Like it's almost like I'm like 25 is almost kind of multiplying the effectiveness of my 5-cent coin. And so you can you're automatically safe above, like, you know that 3/4 will never be the worst thing to do than using nickels, because
Right.
you already have that sort of 5-piece in there that's being, like, the other way to look at like 3/4 is 3 times 5 times 5, which is 15 of the 5-cent coins.
Okay, right.
And so as long as you can find the least common multiple, then that means you're sort of aligning your parentheses so that there's no way that above that certain point, there's no need to sort of worry, because you're already being covered in that sense.
Yeah, that makes sense.
Yeah.
Thanks.
All right, that was my question. So I'll have some more feedback, but in general, I thought it was really well done. And yeah, if you have any questions for me, I'd be happy to answer them. Otherwise, I'll just leave some feedback in the platform.
So I mean, I was just curious. Like, this is my first time trying this, and I mean, I've not like, what can I ask, or what should I ask, or what am I supposed to ask? Like, I was curious, like how, or like being an interviewer, like how does it help you, or like why are you doing this? I don't know if that's the right question to ask, but like I was just curious.
Yeah, so a couple things. I mean, number one, I do get paid for it, so there's that incentive. But also, I've done a lot of interviewing in the course of my career. I've been on both sides of the interviewing table, like both interviewing and being interviewed. And I think it's kind of an interesting process, but also I think that it's one of those things that's it can be very intimidating, and it can be very like frustrating, and you can get really nervous and built up about it. And, I have certainly failed many an interview, and, never gotten past phone rounds and all this other kind of stuff. And I just found for myself that practicing and doing it over and over again really helps to solidify it and make me sort of be better at going in and doing interviews. And so in that sense, I want to be of some help to people who like want to be better at it. So yeah, there's that kind of motivation as well.
So I completely agree with that practicing like solidifies it, but like, again, like these things you don't really use at work, and like if you don't practice it for like say 6 months or even a year, like you kind of lose touch, and then you have to like practice again a lot of times, right? I mean, I don't know if you agree with that. So like I mean, just like, how does it help in assessing someone if someone who hasn't practiced is not able to solve it, and who has been practicing it for months and then like is able to do it?
That is an excellent question, and that is the $1 million question, actually. That there's a lot of companies, especially the bigger companies, like Apple and Google and such, are famous for this, that they keep trying these different things, and they try to do interviews in different ways. And there's definitely this acknowledgement that like doing coding challenges like this is not perfect. But the thing is that no one's come up with anything necessarily any better.
Yeah,
that's really where it comes down to, is that everyone looks at this kind of stuff and they say to themselves, there's got to be a better way. And yet when it comes down to, trying different things, and so I used to work at Google, and they're constantly tweaking their interviewing style. And, as an interviewer at Google, you're constantly being told, well, you should try doing this differently, or doing this like a new way, and all this stuff. And, for a while, they really liked asking these kind of brain teaser questions, much more like logic stuff. And then that went out of fashion. And then they said, well, you should ask things that are really specific to your work. Like take an example of something that you were working on that day and ask them about it. And then that turned out to, some people were better at those, but not as good at others. And it just the problem is there's just no one right answer. There's no one right thing. And at the end of the day, if you are going to be a software developer, sure, you might not have to, play these little math games, but a lot of it is just being able to see, like, do you remember how to code? And, not all positions involve a lot of coding, but, a lot of times companies don't want you to be afraid of it. So just being able to see that you can, close your curly brackets in the right way is something that people want to see. And just sort of the mathematical mind. I mean, in a real interview, there would certainly be another element to it, which would be asking about, your background and your thoughts on the company and the product and all this other kind of stuff. That's a lot harder to sort of have a platform for practicing in a uniform way. So this is also kind of, focusing on one element of the technical interview, but it's an important one. As little as people want it to be true, like I have had very qualified and competent engineer friends of mine who I worked with, and I knew they were really, really good at their stuff. And, one example, the guy went in for a Google interview. They said, no, we're not going to give you an offer because you coded too slow. Wow, right? Didn't get an offer because he coded too slow on the whiteboard. And you don't want it to be that way. You really don't. You want to be able to say, hey, but this guy's got 20 years of experience doing this, and he knows his stuff, and he's a super expert in all this, and he's super smart, and he'd be a great addition to the team. Why are you not letting him on? Because he's coding too slow. But the problem is that, from the company's perspective, they only have so much time. They only have this small window into what your background is and what you can do, and they only have so many signals. And this idea of solving problems, in a sense, like solving problems with code, is kind of what a lot of software developers do in one sense as part of their day, and just making sure that piece is rock solid is important to a lot of companies.
Yeah, I see that.
So, yeah, I mean, it would be great if there was another answer, but for the time being, like in this day and age, for what we know about interviews, this is kind of how they're done. So It helps to practice, it helps to get that stuff down, and yeah. So I hope that's some kind of answer.
Yeah, definitely. Yeah. I mean, thanks a lot. I mean, I had a great experience doing this. Well, it was my first time, and definitely liked it.
Cool. All right. Well, glad you enjoyed it, and I thought you did really well. So yeah. Otherwise, good luck on your future practices and real interviews, and have a good rest of your night.
Thanks. You too.
All right. Take care.
You too. Bye.